Example 8.1. In a young double slit experiment, distance between the screen and slit is 2 meter. Wavelength of the light used is 5 times 10 power of negative 7 meter. If the distance between the central interference pattern and the 10 bright fringe is 3.4 centimeter. Okay, calculate the separation distance between two slits and distance between two adjacent bright fringe. Okay, so we list all the information given first. So D is equals to 2.0 meter. Wavelength equals to 5.0 times 10 power of negative 7 meter. Ym or Y10 is equals to 3.4 centimeter. Okay, A, the separation distance between the two slits. So D, small letter D. Okay, the formula we have to use is Ym is equals to M lambda D over D. Okay, we rearrange D as a subject. So D is equals to M lambda D over Ym. M equals to 10. Lambda equals to 5.0 times 10 power of negative 7. D2 Ym equals to 3.4 times 10 power of negative 2. So distance between the two slits is equals to 2.94 times 10 power of negative 4 meter. Okay, now B, distance between two adjacent bright fringe or delta Y. Okay, so the formula we have to use is delta Y is equals to lambda D over D. Lambda 5.0 times 10 power of negative 7 times 2 over 2.94 times 10 power of negative 4. So the final answer is 3.4 times 10 power of negative 3 meter. Example 8.2. An oil film floats on water. The refractive index of the oil and water are 1.3 and 1.33 respectively. If the oil film has uniform thickness of 100 nanometer, calculate the maximum wavelength of reflected light for destructive interference. Okay, we try to sketch the figure first. So we have water, oil, and air. Okay, given that refractive index water is 1.33, refractive index oil is 1.30, and we have to remember that refractive index air is equals to 1.0. So the question asks you to calculate maximum wavelength for destructive interference. The formula we have to use is 2nt is equals to m plus half lambda. Okay, we rearrange lambda as a subject first. So lambda is equals to 2nt over m plus half. For maximum wavelength, M should be 0. So 2 and oil is 1.3. Thickness oil is 100 nanometer. M0 plus half. So wavelength is equals to 5.2 times 10 power of negative 7, or we can write as 520 nanometer. Example 8.3. Light from two sources passes through a 0.5 mm wide slit. A screen is placed 2 meters behind the slit. The second bright fringe from a 633 nanometer light source overlap with the third dark fringe from an unknown light source. Calculate the wavelength of the unknown light source. Okay, so A is given as 0.5 millimeter. D is equals to 2 meter. Okay, lambda 1 is equals to 633 nanometer. The question asks you to calculate unknown wavelength, which is labeled as lambda 2. Okay. The second bright fringe, Y2 bright, is overlap with third dark fringe, Y3 dark. Okay, so first of all, we have to remember the formula for single slit to calculate constructive interference. That is, Yn is equals to n plus half lambda d over A. And formula to calculate destructive interference for single slit is Yn is equals to n lambda d over A. So for bright or constructive interference, n plus half lambda d over A equals to n lambda d over A. Okay, so A, which is wide slit, is same, so A can be cancelled out. D also can cancel out. So now we substitute the value. 2 plus half lambda 633 times 10 power of negative 9 equals to 3 lambda 2. So lambda 2 is equals to 5.28 times 10 power of negative 7 meter, or we can rewrite as 528 nanometer. Example 8.4. Young's double slit experiment is performed using light of wavelength 589 nanometer. Okay, this is wavelength. The distance between the slit and screen is 2 meter. So this is capital letter D, distance between slit and screen. The 10 dark fringe. Okay, this is dark fringe. 10 dark fringe is observed at 7.26 mm from the central bright. So number of order for 10 dark fringe is equals to 9. Okay, sebab first dark fringe is a 0 order. Calculate the slit separation. Okay, slit separation, small letter D. Okay, so A, to calculate a slit separation, we have to use formula ym is equals to m plus half lambda d over d, dark fringe, destructive interference. So slit separation D is equals to m plus half lambda d over ym. So m for 10 dark fringe is equals to 9 plus half lambda 5, 8, 9 times 10 power of negative 9. D 2 meter, ym is equals to 7.26 times 10 power of negative 3. So slit separation is equals to 1.54 times 10 power of negative 3 meter. Okay, next B. The distance of the fifth bright fringe. So M is equals to 5. Okay, from the central maximum. Okay, B. Ym is equals to constructive interference, bright fringe. So constructive interference, M lambda d over d equals to m5 lambda 5, 8, 9 times 10 power of negative 9 d2 d slit separation tadi kita dah kira, so 1.54 times 10 power of negative 3. So ym is equals to 3.82 times 10 power of negative 3 meter. Example 8.5. White light is incident on a soap film of refractive index 1.33 in air. The reflected light look bluish because the red light of wavelength 670 nanometer is absent in the reflection. Determine the minimum thickness of the soap film. Okay, this is refractive index water 1.33 and ada air kat sini, so refractive index air is equals to 1.0. Okay, wavelength is equals to 670 nanometer is absent in the reflection. So this is the keyword. So this is destructive interference. Determine the minimum thickness, T minimum. Okay, so first of all, we have to check either this is in phase or anti-phase. Okay, so thin film and soap film. So first layer kita ada air equals to 1.0, and then second medium water 1.33, and then air again 1.0. So from incidence ray from less dense to more dense, there is a phase change, that is pi radian. Water 1.33 to air more dense to less dense, there is no phase change. So satu phase change, satu tak ada phase change, satu ada phase change. So this is antiphase. Okay, antiphase and destructive interference. Okay, so the formula to calculate minimum thickness is 2nt is equals to m lambda. So T minimum is equals to m lambda over 2n. Okay, number of order 1, minimum thickness, lambda 670 nanometer over 1.33 refractive index for thin film. So the minimum thickness is equals to 2.52 times 10 power of negative 7 meter. Example 8.6. Okay, monochromatic light from a helium neon laser of wavelength 633 nanometer is incident normal to a diffraction grating. If the grating consists of 5,000 lines per centimeter, calculate the angle at which second order maximum can be observed. Okay, so lambda is given 633 nanometer. Okay, and then grating consists of 5,000 lines per centimeter. So n is equals to 5,000 lines per centimeter. Okay, calculate the angle at which second order. Second order means n equals to 2. So question asks you to calculate theta 2. Okay, so the formula we have to use is d sine theta n is equals to n lambda. Okay, theta 2 is equals to 2 lambda 633 times 10 power of negative 9 over d, which is d is equals to 1 over n 1 over 5,000 over per centimeter. So 1 times 10 power of negative 2. So 1 over 5,000. Okay, negative 2 ni atas. So times 10 power of 2. So D is equals to 2 times 10 power of negative 6 meter. Okay, then we substitute D here. So 2 times 10 power of negative 6. So theta 2 is equals to 39.3 degree. Okay, done.